Mechatronic systems and control engineering. Just a short introduction to the module as a whole. Learning outcomes. Number one, investigate and critically appraise a range of mechatronic actuators and sensors. Number two, critically analyse a range of methods of control used in mechatronic systems. And thirdly, apply design principles to complete mechatronic system and evaluate the outcomes. Yeah. So there's 3 assessment points for that. No examination. So 3 pieces of coursework. Assignment 1 is about you investigating and comparing actuators used for mechatronic systems and sensors. Assignment 2, investigate and compare 2 or more systems of control used for mechatronic systems. And there what you'll do is look at the difference between a simple microcontroller or embedded microcontroller, use a little Genie system here, and PLCs. Yeah. And the third thing is the design solution to a mechatronic problem or a mechatronic project that we've talked about. So these 2, 1 and 2, will run through the module. I'm going to issue assignment 1 next week. That'll run for 4 weeks. We'll review that, and then maybe a week or 2 later, assignment 2 will be issued, and that'll have a 4-week window to be completed as well. This one, I started that project about halfway through the module last year, and that weren't really long enough to make a viable. We got it done, but that was a push, and so I'm going to be looking to start that much earlier. Probably start that the week after half term, which is week after next. So we're here next week. Then I'll introduce assignment 1 next week. Then we've got half term, and we'll have the project ready for issue the week after. And I have, although in previous years I've done a group project, I'm pretty much set. You're going to do something individual this time. All right. So, but never say never. I often change my mind when I look at things, but that's the way I'm thinking. Let's do something individual, similar but individual. All right. So that's an overview of the whole module. So what we're going to just have a brief discussion about is what is mechatronics. I found I don't often pick too much off Wikipedia, but I thought that statement pretty much summed it up. Mechatronics is a combination of mechanical engineering, electronic engineering, computer engineering, software engineering, control engineering, and system design engineering in order to design and manufacture useful products. Mechatronics is a multidisciplinary field of engineering, that is to say, it rejects splitting engineering into separate disciplines. If you think of separate disciplines, you could get the situation where, you know, there's a specification for a mechatronic system or problem to be solved. The mechanical guys go off and design their bit, electrical guys go off and design their bit, and they aren't compatible with each other, for instance. Yeah? Or your electrical engineers pick some sensors that don't match the control system that your control engineers tick. So if you pull all of that together and put together a multidisciplinary team that work closely, they all work together on solving that same problem, then you're talking about mechatronics. That's the way I see it, and that's the way this description of it is talking about it. Yeah. And it's very much is how that would work in an industry where a company is a machine manufacturer and there's a designer of mechatronic solutions would go about doing that kind of thing in this day and age. rather than separating it all out and having it not joined together in a coherent solution afterwards. Yeah. So, if we take a mechatronic system, there can be many, depending on the size of it and the size of the problem, there's a lot of things that could need looking at. In terms of mechanical system, actuators, solenoids, coils, motors, stepper motors, servo motors, hydraulics, pneumatics, and so on. Sensors, switches, strain gauges, potentiometers, thermocouples, photoelectrics, and so on. We could think of hundreds of different ones, depending on how finely we split it up. Input signal conditioning and interfacing. So we might have to change a voltage value to current, or an air pressure value to a voltage or current. So we have to condition signals so that they match what signal our control systems need to actually carry out that control. Digital control architectures, logic circuits, microcontrollers, PLCs, and so on. There's a number of different things that you could consider in that area as being important to any mechatronic system, things that you could have to look at. And then we've got our output from our control system. We may need to again condition those signals so that they will actually control a real thing in the real world, a motor or a valve or some other device. So we've got digital to analog conversion, digital to digital, amplifiers. We might want pulse PWM, which is pulse width modulation, and so on, which then goes out to some kind of display possibly, so that the operators can know what's going on. So that's another facet of it. Human-machine interfaces, as they call them these days, as well as you might have SCADA systems that collect data on what your mechatronic system is doing, if that's big enough as well. So there's a whole host of different things that you could get involved in with regard to any particular mechatronic system. Now, this is a relatively small module within a whole degree. You can easily, if you look around, you can find complete degrees in mechatronics that would have a module in each of those areas. So as you can imagine, you're only going to experience some parts of that through what you do on this course. So open your eyes to some of it, and then if you're involved in mechatronic systems, you'll know how to look around to find solutions to other problems. Okay. Now, one of the things that's listed on that board there, on the actuators, is stepper motors. So what we're going to do is take a look at how stepper motors work. A little bit along what we've done before is, let's have a look at something to the sort of depth you may need to research to, and then when you go out and research something else, you've got a good idea of what we're looking for you to talk about and what depth I'm looking for you to talk about it in. So I'm going to pause the video now so I can make